are really going to change gears now in Unit 9. We've been talking about the Pythagorean theorem in Unit 8 and talking about angles and angle relationships in Unit 7, triangles, angles, all sorts of stuff like that. We're now going to be dealing with some geometric figures, but we're going to be doing something totally different with them. We're going to be doing something called a transformation. We'll talk about what those are in just a second, but the I can statement for section 9.1 is I can understand and perform translation. So go ahead and write the word translations there. A translation is a type of transformation. We're going to have a lot of vocabulary to learn. It's going to seem kind of weird to begin with, but you'll get used to it. And some of them are very descriptive. And a translation is one of those that we're going to come up with kind of a simpler vocabulary word to describe that. But in the warm-up, we've got a couple things that we want to do here. It says graph and label the following points and connect them to form a figure. So we're going to start with the point P. And so when we see a capital letter like this, that's going to indicate a point. And then this point is going to have coordinates -2, 1. So we're going to come over here to the graph, and we're going to go to -2, 1. So that would be right here. And we're going to put a P right by that, so we know that that's point P. This is point Q, so we've got 2, 4, so over 2 and up 4, so that's going to be right here. So here's Q. And then the last one is point R. R is at 0, -3, so we don't go right or left, we just go down 3. So we're going to put R right here. And then we're just going to draw lines to connect these. So it said connect those points to form a figure. So we've got a little triangle right there. All right, now the next question in the warm-up is, what does the word transformation mean? Well, if we transform something, if it undergoes a transformation, like a butterfly transforms from a caterpillar into a butterfly, so it changes. So when we say transformation, or when we say something transforms, what we mean is it changes. So transformation means a change. All right. So last question seems a little bit random, but it says, have you ever set a table with placemats? I'm hoping for everybody the answer is yes, you have, because we're going to kind of draw an analogy between a placemat on a table and the type of translations that we're going to be doing in today's assignment. So I'm going to slide this down here. We're going to take a look at this information. We're going to be talking about the different types of transformations and kind of categorizing them a little bit and giving a little bit more detail. So I'm going to fill in these and then we'll talk about them. So I've got the first set of blanks filled in for those first few paragraphs there. And let's go ahead and read through this. It says when we transform something, we change it. So again, there's that word transform. It's kind of interchangeable with the word change. So if we transform something, we change it. If we change something, we could just say, hey, we transformed it. Just a different type of vocabulary word, so just something to get used to there. We are going to learn how to transform figures. So we're going to transform shapes that are graphed on the coordinate plane. And we are going to learn about 4 different types of transformations. The first one is called a translation. So that's what we're going to learn about today. We're also going to talk in this unit about reflections, and we're going to talk about rotations, and the last one that we're going to learn about is something called the dilation. Now, translation, not too bad a vocab word. Reflections, you've probably heard of that word before. Rotations, I'm sure you have. Dilation, probably not so much, but we'll deal with that when we get there. We'll kind of give us a quick way to remember what a dilation is. So translations, reflections, and rotations, they are all types of rigid transformations. So the first 3 that we're going to learn about, those are types of rigid transformations. And the word rigid means the transformation does not change the size or the shape of the figure. So rigid mean it kind of stays the same. So we might move it around, we might change it somehow, but it's going to keep the same size and the shape of the figure. So if it's the same size and the same shape, not only are those shapes still similar, they're actually congruent. So go ahead and write the word congruent there. If the size or shape is changed, so if it changes size or it changes shape, then it's called a non-rigid transformation. We don't deal with many of those, but we are going to deal with a dilation. Dilations are the only type of non-rigid transformation that we're going to study, that we're going to learn about in any way. Okay, and most of the dilations we perform, they're going to change the figure so that it's no longer congruent, but it will at least still be similar. So it's going to be the same shape, but maybe a different size, and maybe it moves around a little bit or something like that. But it's still going to be a similar figure. Okay, let's take a look at these others. And let's talk specifically about what a translation is. So we're going to start with translations, and a translation is just a fancy word that means we're going to slide the figure around on the plane without changing its orientation. So we're going to slide that figure around. We might take a triangle or rectangle or trapezoid or something like that, and we're going to slide it around on the XY plane, and we're not going to change its orientation. Now, orientation in this case means the way that that particular figure is pointed. So it's when we get done with it, it may have moved around on the coordinate plane, but it's still going to be pointed the same direction. It's still going to be the same size, and it's still going to be the same shape. So we might move it around, but it's not going to change size or shape, but we might point it a different direction, and that's totally okay. The new figure created by a transformation is called an image. Now, when we say image, what we're talking about there is we're talking about the new figure, and the original figure is called the pre-image. So I'd like you to kind of get this in your head. This is the vocabulary that we're using. The pre-image is the old figure. It's the old way that it used to look, or where it used to be, and the image is the new one, okay? And if the pre-image contains the point P, then the image would contain this point right here, P prime. So write the word prime right here. Whenever we see this little mark right here, it kind of looks like an apostrophe. It's not. It's more kind of straight up and down than that. It kind of looks like maybe the top part of an exclamation sign or something, but you can just put a little mark. So if I were to write down P prime, I'd write it like this. I'd just write a P, and then I'd just put a little mark above it, or something like that. Now, the word prime in this particular setting has absolutely nothing to do with prime numbers. It doesn't deal with prime numbers at all. Prime in this case means new. So you might be familiar with primer. If you're going to paint something that's new, you put some primer on it. It's like an initial coat of paint that seals everything together. It makes it so it can accept that new paint. So prime means new. Don't be surprised if you see that as a bonus question or something like that on a test. So if we had point Q and we made a new point using its coordinates, using some sort of transformation, we'd make a new point, and that point would be Q prime. So we just write a Q, capital Q, same letter, with a little mark above it, a little line above it, that little prime notation. So now we're ready to learn about a translation. So let's talk about how we perform a translation. All we do, they're very simple, is we simply move every point on a figure the same distance and the same direction. So we're going to see how that looks down below here. So I'm going to slide this down here, and we're going to take a figure that's already marked on the XY plane. So we've got this figure AIS right here. And the instructions say, graph the image of the figure using the transformation given. Use proper notation for the image. So remember, this is the pre-image, and we're going to make the image. We're going to make the new one. Now, this might be helpful in the long run. This is the old one. Let me write that down here, spell it right. OLD. This is the old one, and we're going to make a new one. Now, these are the instructions right here. This is a description of the translation. So we're going to take this figure, and we're going to take all the points, and we're going to move them 3 units to the right and down 4 units. So 3 units to the right and down 4 units. So here's what we're going to do. We're going to take point A. We're going to move it 3 units to the right and down 4 units. So we're going to go 1, 2, 3, down 1, 2, 3, 4. So I'm going to put that point right there, and again, I'm going to label this as A prime. Okay, so the new one is going to go over here. So the old one's over here, the new one's going to go over here. It's going to move right 3 and down 4. So let's take I. So we're going to go right 3 and down 4. There's 2 and there's 4, so we're right here. So this would be I, and again, remember it says use the proper notation for the image. So this is the old one, this is the pre-image, this is where the new one's going to go. And we're going to go over 3, so 1, 2, 3, and then we're going to go down 1, 2, 3, 4, and we're going to put a point right there. Now the point that I was moving was S, the old point was S, so the new point is S prime, and then we're going to connect these to make the figure. Now the cool thing about these geometric figures is if you just move the vertices, if you move the points at the corner, you're going to get that new shape over here. So we've got the old one, triangle IAS, the new one, triangle A prime, I prime, S prime. That's the new one, and you'll notice that it looks very, very similar. Okay, so let's do the next one over here. It says 1 unit left and 6 units up. So we're going to take this point, every single one of these, all 3 of these, and we're going to move them left 1 unit and then up 6. So left 1 and then 1, 2, 3, 4, 5, 6. So we're going to be right here. Again, the right notation here would be G prime. this is the old one, and over here this is going to be the new one. And I know that seems a little bit silly right now, but in the long run, if you really help your mind keeps track of which one's the old one and which one's the new one, it's going to be very useful in the long run. So let's take a look at U. Left 1 and up 6. So this is left 1, 2, 4, 6. That would put us right here. Proper notation for U prime. And then left 1 and up 6. That's going to put us right here. That's going to be Z prime. So it looks like this. Okay? So translations are kind of like sliding. So let's write the word sliding right here. Sliding a placemat around on a table. So imagine this was the table and we had a placemat sitting right here. If we took that entire triangular placemat and just slid it to the right 3 units and down 4, it's the same placemat. It still looks the same. It's still pointed the same direction. It's still the same size and all that sort of stuff. All we did was just slide it around. Same thing here. We took this triangular placemat, slid it to the left and up. It's the same placemat. So notice that the pre-image and the image, check out their orientation, their size, their shape, all that sort of stuff. The I is pointed up here. The I prime is pointed up here. For this one, the U is pointed up here. The U prime is pointed up here. So if we compare the old one with the new one, the pre-image with the image, you'll notice that they are exactly the same. They're actually congruent and they're oriented the same direction. So I'm going to just write down congruent and oriented the same. Okay? So they're congruent and they're oriented the same. All right. Now, it would be really nice to have a way to indicate that we're doing a translation without a long explanation or something like that, without a bunch of words. And if you flip the page over, there is. Okay, so this is a function, and we've talked about functions before. Functions do a little bit of math on the numbers that we plug in, and then it gives us an answer in return. So if you take a look at what happens here, the instructions are the same on this one, but this one gives us a function. So we've got a triangle on this one and a triangle on this one. So this is the old one. And that's the old one, and we'll figure out where the new one ends up. But on this one right here, let's think about what happens here. So basically this is saying take X and Y and do this with them. So we're going to change it. That's what the arrow represents. So there's kind of our transformation right here. We're going to change X into X minus 3. So whatever the X coordinate is, we're going to subtract 3 from it. So if we were to go through and write down what these points were, this point right here would be 0, 0. So I'm going to put Y right here. Y is 0, 0. So what's going to happen is we're going to make a new Y, and that new Y would be, we're going to subtract 3 from it. So we're going to take 0 and we're going to subtract 3. So that would be negative 3. And we're going to take 0 and we're going to add 2 to it. So that's going to be negative 3 comma 2. So the old y was at 0, 0. The new y is at negative 3 comma 2. So I'm going to take that and we're going to go, let's see, negative 3 comma 2. So that would be right here. That would be y prime. Okay, so that's going to be the new one over here. So here's the old one, here's the new one. So if you think about what happened here, this y got moved left 3 and then up 2. So I'm going to go ahead and write that down here. In fact, I'm going to zoom in here. This is left 3. And the plus 2 moved the graph, moved that point up 2. So we can do this point by point like this, or we can just say, hey, I'm going to take every one of the x's and I'm going to move them left 3. See how this is kind of shorthand for what we were talking about on the other page? So we're going to go left 3 and up 2. So I'm going to put that right there. There's z prime. Left 3 and up 2. So we're going to put that right there. That's L prime, and then we're going to connect the 2 of those. Or sorry, the 3 of those. So notice this is the old one. This is YLZ, and this is Y prime, L prime, Z prime. Make that look just a tad better. Okay. Here's the translated figure. So we've translated this from right here over to there. So we've gone left 3 and up 2. It's the same shape, it's the same size, it's oriented the same way. So we just did a translation. We slid it from this place over to that place right there. So again, nice little shorthand, easy to work with. Let's take a look at the next one. Let's see if we can figure out what this is going to do. This is going to take all of the x coordinates and it's going to add 4 to them. So if you add 4 to an x coordinate, that's going to move it to the right 4. And if you subtract 1 from the y coordinates, so if it used to be y, now it's going to be y minus 1, that's going to move it down in the y direction. It's going to move it down 1. Okay? Now, I am going to take this particular point right here. I am going to take u. So u is at this point right here. It's at, let's see, 2, 4, 5. So that would be negative 5, comma, negative 1. Okay? And then we want to make this new point. So we're going to add 4 to this, and we're going to subtract 1 from that. So let's see, this is going to be negative 1, negative 5 plus 1. Negative 5 plus 4 is negative 1, and negative 1 minus 1 is negative 2. So let's see if we end up in the right place. This is going to be u prime is going to be at negative 1, negative 2. So back 1 and down 2. So this right here is u prime right there. Now, does that fit with what we said it was going to be? We're going to move to the right 4. There's 1, 2, 3, 4, and then down 1. Looks pretty good. So let's stick with that. Let's go to the right 4, and let's go down 1. So here would be u prime. Let's go to the right 4, and then down 1. Here would be w prime. Let's go ahead and connect those, and we should see two shapes, two placemats if you want to think of it that way, that look exactly the same. They're oriented the same way, same size, same shape, they're congruent and everything. It's just that the new one, the image, is over here. It's been moved to the right 4 and then down 1. So we've got the old one, the pre-image is here, the new one, the image is right there. Now, this type of notation that we used up here is called a function. And if you'll remember when we were talking about functions before, one way that we can write down a function is we can do a mapping from x to y and stuff like that. So this type of notation is called a function because it tells us how to map the old points onto the new point. So that's what we're doing. We're taking the old point and we're mapping it to a new point. We're taking the old point and we're mapping it to a new point. So we'll do a little bit of practice just with coordinates. You do have some assignment problems where all it says you need to do is just change each one of these points into the new point. So we have T, O, and E. So we're going to have T prime, the new point, we're going to get by taking every one of the x coordinates and we're going to subtract 2. So if I subtract 2 from that, I get negative 6. We're going to take every one of the y coordinates and we're going to subtract 10. So that's going to be negative 3 minus 10, so that's going to be negative 13. And you don't have to graph this or anything. All you need to do is use the right notation. So on every one of these, we're going to subtract 2 from the x, subtract 10 from the y. Subtract 2 from the x, subtract 10 from the y. And that's going to make O prime 1 comma negative 11. That's going to make E prime, let's see, 2 minus 2 is 0. And then let's see, that's negative 15 right there. Okay, so we've got each one of those new points right there. That would be the answer to the problem. And then on this one, we're supposed to take every one of the x coordinates, and the new x coordinate is going to be the old one plus 3. So whatever the old x coordinate is, we're going to add 3 to it. So I'm going to add 3 here, and every y coordinate is going to get 1 subtracted from it. So we're going to subtract 1. So I'm going to go ahead and write down what we're going to do to each one of these coordinates. So we're going to add 3, subtract 1, add 3, subtract 1. So then we go through and we're going to have j prime, so this is going to be 6, comma 2. A prime is going to be, let's see, that would be 10, comma negative 5. And m prime, that's going to be 8, comma 1, because 2 minus 1 would be 1. All right, so we circle that and we're done. You've got some problems that literally all you're doing is you're using this function to map the old x coordinate to the new x coordinate. Whatever that number is, we're going to just, in this case, add 3, and we're taking the old y coordinate and mapping it to a new coordinate by just subtracting 1 from it. Okay, so on the next example, on 4, it says write a function, a mapping, if you want to call it that, and a verbal description to describe each transformation. Now here's where it's useful to look at this, and now I've got this one on here in black and blue. If you're using a set of notes that's just printed in black and white, then you need to pay attention to the notation. So this is f and this is f prime. That automatically tells me that this is the old one and this is the new one. Now that may not seem like a big deal, but it is, because if we go from the old one to the new one, we're going to take this point and we're going to move it to the right. 1, 2, 3, 4, 5, 6. We're going to move it to the right 6 units. If we thought it was going the other direction, we would be moving it to the left 6 units. So you've got to make sure that you know which one's the old one and which one's the new one. Now the verbal description might be easy for you. You'll notice that we took F and we moved it 6 units over here. We didn't move it up or down. Okay, so we go right 6 units. If we get pressed for space, then we'll just say right 6. We won't put the units on there. So if we were to write a map for that, then here's what we're going to do. We're going to take the old x coordinate, and if we want to go right 6, we're going to add 6 to the old x coordinate. Now you'll notice that it didn't go up or down, so we don't have to change the y at all, so we keep the old y coordinate. It doesn't transform at all. We're not moving it anywhere. So if we wanted to move a figure right 6 units, then all we'd have to do is set up a mapping that shows xy being mapped onto x plus 6 and then keep the y coordinate the same. Okay, so again, please make sure you have the order correct. It's really helpful if you write old and new next to the figures to keep which is which straight, and so that you can tell which direction you're moving. So let's take a look at this next one. We'll keep our advice here. This is the old one and this is the new one. Let's think about what's going on here. If I were to pick L and L prime, I'd start here and I'd have to go back 1, 2, 3, 4. So I change the x coordinate by subtracting 4, okay? And then I change the y coordinate by going up 2, so that would be plus 2. So we're going to take the old x coordinate and we're going to subtract 4. And we're going to take the old y coordinate and we're going to add 2 to it. And what that does, so our verbal description is, it takes the old one and moves the entire figure, doesn't change the shape or the orientation or the size or anything. It slides it back 4, left 4, and then up 2. So I'm just going to write left 4 and up 2. So left 4 and up 2. For that translation right there. Okay, all right, let's slide down here, and I've got a little bit of a summary. So we've got right is going to be a plus, left is going to be a minus, h units depending on the sign. So you'll notice that what changes here is we went from x and we're going to change that to x plus or minus h. We're only moving left to right, so that means the y is going to stay the same. So the y stays the same, but it's going to move to the right if it's positive. So if this was plus some number, then it's going to move to the right. If it's negative, if it's a minus, that's going to be moving to the left some amount. And up or down. Up if it's positive, down if it's negative, k units, so I've changed the number that we're using depending on the sign, and you'll notice that we've got the y plus or minus k. So if we're moving up or down, what we're doing is we're changing the y coordinate from the old y coordinate, and we're going to move up if it's a plus k, we're going to move down if it's a minus k, and if all we're doing is moving up or down, then we don't change the x coordinate at all, so we're going to just put an x right there. And it is possible to do more than one translation at a time. So we could take x and we could either add or subtract h, and we could take y and either add or subtract k, and that's going to move it left or right depending on whether it's positive or negative, and that's going to move it up or down depending on whether it's positive or negative. So hopefully that is enough of an exposure to that right there. Translations really are pretty easy. We're just sliding them around, but I do want to make sure that we're ready for the next section. So to prepare for tomorrow's assignment, I want you to do the following. Graph and label each of the equations, or each equation on the axes over here. So y equals x. Now remember, if you have y equals x, we're thinking y equals mx plus b. The y-intercept would be 0 and the slope would be 1. So that means it would cross at 0 and rise 1, run 1. So it would look like this. So perfect 45 in the upward direction. Draw a nice line here, make that look good. We'll label that after we put arrows on it. So this is the line y equals x. I'm going to change colors and we're going to look at y equals negative x. Same thing, the y-intercept would be 0, so it's going to cross right here, and then the slope, instead of being positive 1, is negative 1. So we're going to go down 1 and right 1, down 1, right 1. So it looks like this, perfect 45 in the negative direction. Got all those points right there. We're going to connect these, put an arrow on the end, and it did say label them. And the nice thing about labeling this is it's just a great reminder of which equation it is. So we've got y equals x going up, we've got y equals negative x going down, and then we've got y equals negative 2. Now if you remember, y equals a number is a, which is it? Is it horizontal or vertical? Remember, it crosses the y-axis at 2, so let's see if we can figure this out. It crosses right there, And then as long as y, whoops, should be -2, as long as y is -2, x can be anything we want. So we can go as far as we want in the x direction, to the right or to the left. So we get this right here. This is y equals -2. That is a horizontal line. Horizontal. Okay, well that means this last one that's remaining, let's see if this makes sense, x equals -1. So that means it's going to cross the x-axis at -1. The only condition for a point that's on this line is x has to be -1. Y can be anything we want. So we can go as far up as we want or as far down as we want. So that would be x equals -1, and that is a vertical line. Okay? All right, hopefully that's a good review. You are going to need to be able to graph those and remember what those lines are really quickly for tomorrow's assignment. Good luck on